Welcome to the area and perimeter of regular figures podcast. So we're going to be looking at the equilateral triangle and the square, which are regular figures, and the isosceles triangle, which is not regular because it only has two sides and two angles congruent. However, it has some similar properties, so I included it in this podcast as well. On your notes, it says area and perimeter, and you had step 3. I decided to leave the area portion out of this particular problem because it would be very similar in steps to what we're going to see with the isosceles triangle, except for that problem we already have the triangle, and here we don't have the whole triangle. So we'd have to be finding one of the other points, or where one of the other points could possibly be, to use that property. And so I decided, let's just do perimeter on this one, and we'll save area for the one that has the triangle graphed. All right, so step 1. All right, we have one side of an equilateral triangle, and it has endpoints 2, -5, and -3, 7. We're just going to find the perimeter in square units of the equilateral triangle. All right, so, and actually it will just be in units because we're not finding the area. So find the length of one side. So you should graph the points, already graphed them in advance, and we're going to use the distance formula. So graph those 2 points, and we'll connect those so we can kind of see one side of our triangle. And that'll be enough for us to calculate out the perimeter. We might want a little bit more for the area, like where the other point is. Now, the other point on the triangle is either over here somewhere, and we could calculate it out. It might take a little trial and error, but we could calculate it out. And maybe, depending on how long this podcast is, maybe I'll come back to that particular problem. If you notice here, it almost looks like maybe, I don't know, does that triangle go through 0, 0? Is my line really crooked? I think my line might be really crooked. I should probably make that a little straighter, huh? So our third point is either on one of those two sides, but I don't think we'll spend the time finding it. I think we'll just focus on perimeter for this problem, okay? Because that's actually the most important concept for this particular triangle. So we want to find the length of one side, all right? So let's use the distance formula, all right? Remember the distance formula is the change in x squared plus the change in y squared, all right? So I'll just start with the first point I see. So -3 minus 2 squared plus 7 minus -5 squared, all right? And then we simplify. So that would give us -5 squared. Don't forget your parentheses. The negative is squared. And then 7 minus a -5 is 12. That would be 25 plus 144. And that's going to give us 169, square root of 169. Well, that is a perfect square. It's 13 times 13. So that means that one side is 13. Well, guess what? This is an equilateral triangle. So since all 3 sides are the same, if we just take one side and multiply it by 3, since they're all 13, we'll have our perimeter. So our perimeter is going to be 3 times 13, or 39 units. And that's it for finding perimeter. Now, we could work to find out area, but if I wait and we do this problem in the second semester, you will have learned some more skills that will make finding the area much, much easier. So we're gonna hold off on area. I changed my mind and decided to hold off on area for this particular problem. So we're on to the next problem. That was pretty quick, huh? 4 minutes, we're done with one problem. We got 3 to go. 2 to go, just 2 to go. Area and perimeter of regular figures, the square. So one side of a square has endpoints, -4, 2. Let's graph that, and 8, 7. 1, 2, 3, 4, 5, 6, 7. Right there. Right. And we'll connect those points. It just kind of, I don't know, to me it helps us kind of visualize the square a little bit better. So the other 2 points are either somewhere up here or somewhere down here. And this actually wouldn't be that difficult to calculate out using slope. Okay? We could actually use slope because something that we know about, and actually, you know what, I think we'll graph, well, we could graph 1 point of it. Let me see. I don't remember if I have graphing the 4th point on here as well. Or was this my last slide? Yeah, I think I took off graphing the 4th point of a square given 3 points. But we actually could graph a possible 3rd point. And actually, let me show you where that might be. So if I look at my slope here, the slope here would be, so 7 minus 2. So this is just a little extra. And 8 minus a negative 4. So that's going to be 5/12, right? So if that line has a slope of 5/12, oops, the side adjacent to it has to have a slope of, hopefully you all know, negative 12/5, right? Perpendicular lines have slopes that are negative reciprocals. So I don't know whether it's, whether it's up here or down here, the 3rd and 4th points, but I could at least graph one of them here because there's down here because there's enough space. So let's graph it down here. All right, so I'm just going to count. And actually, put this in your notes too, just so you have kind of a better sense of how you would find missing coordinates on the square. All right, so if we count down 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and to the right 5, 1, 2, 3, 4, 5. This is one possible location for the 3rd coordinate of the square. The other one would just be if I counted the other direction, if I counted up and to the left, right? That would also give me another point, but I think that's going to be right off the graph. Yep, right off the graph. So that's why I chose that one over there. And actually, I wonder, can we fit the 4th point in our square? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5. Just barely. So this is one of 2 possible locations, by the way, for the rest of the square. Now, it was not needed that we graph, boy, this is that a crooked line. It was not needed that we graph the points of the other 3 points of the square, but I did think I should take the opportunity to show you how you'd find it. So if you're looking for missing points on a square and you're given 2 or 3, use slope. To find the next coordinate on a square, because this is a right angle here, adjacent sides are perpendicular, right? So we can use slope. Now we're going to find area and perimeter. We're going to find the perimeter, the length of the side, using the distance formula, and we can use that to find perimeter and area. But on this problem, we could also use our box method. So, that might not be a bad idea to just review the box method one more time. So, I am going to, since I spent less time on the equilateral triangle, I'll spend just a tiny bit more on the square. All right, but let's answer this question. All right, so we'll find the length of one side, distance formula. All right, so we're going to use the ones we were given. Right, we're going to use those points there. All right, so -4, because we didn't really have to graph, right, that whole square. I just wanted us to. All right, so -4 minus 8 squared plus 2 minus 7 squared would give us -12 squared plus -5 squared, which is 144 plus 25. And if you remember, that's 13. I guess I need more unique numbers. Right? I always try to give you numbers that were perfect squares. I should have chosen another perfect square. So to find the perimeter, if we know one side, It's really easy. On the square, the perimeter is just, since they're all the same length, we can just take that one side and multiply it by 4. So that means our perimeter of our square here is 4 times 13, which is 52 units. And that's a lot easier than having to use the distance formula on all 4 sides and add them up. Right? We would get the same thing if we just did the distance formula once and multiplied by 4. To find the area on a square, the base and the height are the exact same measurement. So area is, on a square, is the side squared. And so side squared is going to be the same as base times height for the square. So that would just be 13 squared, which is 169 units squared. How about that? Look at that. It's the side squared. Well, who'd have thought, right? So that's all you'd have to do in this particular problem. If you were just given 2 points, you could find the length of the side, you could find the perimeter, and you can find the area. And if you use slope, you can actually find the other coordinates. Now, like I said, this is only one of the 2 possibilities. It's possible that instead of this being sort of the top right there of my square, it's the bottom. But if it's the bottom, it doesn't fit on my graph, so I don't want to graph it. Let's look at this problem one more time using the box method. Using the box, oh, there it is. All right, so this is, I'm going to erase all of this. And you have some extra space. Maybe if you can, maybe even just squeeze the box around it, maybe do the work on the other side. And this was supposed to be at -4, 2. So this is supposed to be right here at that point. A little off on the lines there, just a little bit. Well, can I say with the line tool here? All right, so if I use the box method, right, I just box my square in. And how about make some straight lines? So you know what? It may not be perfect, but I think my line tool looks a lot better, but we better choose another color, otherwise it's all going to look the same. Here, I'll use orange. All right, so, and I'll fix the line. All right, so we box in our figure. Oops, that went too far. Oh, and this line had to come up some. All right, so now box it in and then I'll fix it. All right, so this one I didn't make far enough, right, because I didn't come up to the other one. So if you make a mistake, that's why pencils have erasers and there's such a thing as whiteout. You just fix it. And this one needs to come in a bit. And these were too long. All right, so we box in our figure so that all the vertices all the vertices of the square are on our box, and we can find the area this way. So here I'm going to just use the box method to kind of review. Right? And if you want to review with me, this is a good one because I think I put one like this on the homework. So this would be using the box method. All right, so the area of the rectangle. All right, so I am just going to count. I'll put the coordinates up here. So this is -4, 1, 2, 3, 4, 5, 6, 7. Oops. And this is, where am I located? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13, 7. So -4 minus 13 is going to be 17. Right? And then if, of course, this let's find the other side going. I don't have to find all 4 sides, right? For the box method, for the rectangle, right? I only need 2. So I have the base. So our base is 17, and our height. What do you think our height will be? All right. So -4, 7, and -4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that -10? All right, so yes it is. So then it would be, our height would be 7 minus a -10, which is, surprise, surprise, it's 17. You box in the square, you get another square. All right, so the area of our rectangle is 17 times 17, or 289. All right, and then we'll find the areas of the triangles. So 1, 2, 3, 4. Let's find the bases and heights of all these triangles first and see what we notice. 1, 2, 3, 4, 5 is that base. What do you think this one is? If you say 12, you're right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Actually, I know that it's going to have to be. And I'm not going to tell you why right now. All right, so 1, 2, 3, 4, 5. But a little later on, you'll know why. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How about that? And notice this one is 1, 2, 3, 4, 5. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, how about that? They're all the same, aren't they? 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So why should I calculate out the areas of 4 triangles that are exactly identical? So let's calculate out the area of one triangle. Right? And we'll just multiply it by 4. Right? So I'm going to put area triangles because I'm going to do all 4 at the same time. So I've got 4 triangles, and the area formula for area of a triangle is 1/2 base times height. So that's going to be 4 times 1/2 times 5 times 12. Right? So half of 4 is 2, and 2 times 5 is going to give us 10, and then 10 times 12 is 120. Right? So now let's take our area using the box method. Just kind of ignore all this. I post this, I'll get rid of all this. Just kind of plan of just ignoring all of this because I didn't take the time. I just decided on the spur of the moment to do this. All right, so the area of our polygon there, which we already know is a square, is 289, the area of the rectangle, minus 120, the area of the triangles, which is, surprise, surprise, 169 units squared. Isn't it nice when things work out 2 different ways? So look at that, 2 different ways to find our answer. Box method and distance formula on this, and then squaring that one side. All right, so look at that, 2 different ways you can get the same answer. That's always nice to find, right? All right, so this is with the box method, and over here we used finding the length of one side and using the properties of a square. So we got a lot out of this square here. I think for future lessons, I'll include all of that we just did. The last thing we're going to look at is the isosceles triangle. So the altitude of an isosceles triangle is in the blank of the triangle. Well, it is the altitude of an isosceles triangle is the, let me just move, I'm sorry, I have a screen recording box and it's blocking half of my thing there. All right, is the, what I want to say. Excuse me, let me read my sentence again so I can remember what I intended. The altitude of an isosceles triangle is the distance from the center of the base of the triangle to the vertex. I left so many blanks in here, I had to rethink what my sentence was. All right, so the altitude of an isosceles triangle is just the distance from the center of the base of the triangle to that opposite vertex. So that means we need to know where the center is. Now I'm telling you that D is the midpoint. I'm giving this to you. It's right there. And this is only for the isosceles triangle. On the isosceles triangle, these are the 2 congruent sides. This is our base. These, by the way, are called legs, like in the right triangle. So base, that's the legs. This is the altitude. You should probably label. I am labeling, so you should probably label too. And it does happen that these 2 are also congruent. And we'll actually prove that in a later lesson. And those two angles are congruent. Those angles opposite those congruent sides are congruent. So those are some features of that particular triangle, and that's only the isosceles triangle. And the equilateral triangle would be similar because it is a type of isosceles triangle. So we're going to use the midpoint formula to find the coordinates of D. Right? So remember our midpoint formula, super easy. It's just you add the x's, divide by 2, add the y's, divide by 2. Right? Oh, I need more space. Can I move this? Yes. Don't you wish you could do that? Now I'll put that there. All right, so that's going to be negative, our midpoint is negative 4 plus 2 divided by 2, and 1 plus negative 3 divided by 2. All right, so that gives us negative 2 divided by 2, and negative 2 divided by 2, which means that is point is, oops, I have an extra parentheses in here for no apparent reason. There we go, good enough. That point therefore is negative 1, negative 1. That's our midpoint. So now all we need, oh, I can't move it in closer. Sorry, it's good enough, right? So all we need now, so we know this point here is at, I got so much stuff in here, is at negative 1, negative 1. So the only things we need for area, we need to find the length of the base, and we need to find the length of the altitude. Right? That's all we need. Right? So the length of our base is AC. That's why I said find AC. So that's going to be, we'll use our distance formula. Right? And so that would be negative 4 minus 2 squared plus 1 minus negative 3 squared, which is negative 6 squared plus, that would be 4 squared, which is 36 plus 16, and that's going to be 52. Square root of 52. That does simplify. Right? So square root of 52 divides by 4. 4 will divide into 52 13 times. So, and 4 is, oops, sorry. Yeah, I can't use full screen on this either when I'm recording, and I hit the expand the page. Let's bring it back. There we go. And now I have a screen recording box in my way. Okay. All right, we'll squeeze that in and not right at the bottom. There we go. 2 and 2, and 1 2 comes out and 1 2 goes away. All right. So this would be 2 square roots of 13. Hopefully you're okay with that. Hopefully you can see enough of that. I can't get rid of the stupid box. All right, so that's the length of AC. All right, so AC is our base. I think I wrote too big. You have to rewrite this much smaller. And that is 2 square roots of 13. All right, and now let's find dB. That's our altitude. Right? And so that we're going to use the, it's crammed in negative 1 there, and 3 4. So this would be 3 minus a negative 1 squared plus 4 minus a negative 1 squared, which gives us 3 plus 1, that'd be 4 squared, plus 3 minus a negative would be plus 5 squared. Right, so that's going to be, looking for places to write now. I think I can squeeze it into one more line. 16 plus 25, which is 41, right? Yes. That doesn't simplify. All right, so our area, so the numbers aren't pretty, but it's okay. It's okay. Our area is 1/2 times square root of 41 times the square root, 2 square roots of 13. Now, what do you do when you multiply? Number by number, radical by radical. So for my area, I'm going to multiply the 2 times the 1/2. That's a number. It's not in the radical. Come on, 1/2. Any day now. And then I'm going to multiply the square root of 41 and the square root of 13. You multiply the stuff in the radical. You can multiply radicals that have different values so long as, or whatever. All right, so man, I don't know where to squeeze anything in anymore. I'm going to get rid of this, all right? You can't even really see it anyway. And I think you understood how we got the 2 square roots of 13. Anyhow, all right, so 2 times 1/2, that's simple, right? That's 1, right? So now I just have the square root of 41 and the square root of 13, right? And I'm going to grab a calculator because, well, I'm tired and it's late and I want to do it quickly. Although now I'm thinking I could have done it faster in my head than grabbing the calculator. All right, so 41 times 13 gives us 533. So we have the square root of 533. And I don't know if that's divisible by anything. 533, it's not divisible by 3 because those numbers don't add up to 3, not divisible by 2, 4, or any even number. Not by 7, not by 11. And actually, let's think about this for a moment. So if we think about 41 and 13, and we just take one single moment to think before we do any math, we'll realize that that is not simplifiable. And you know how I know that? Now that I'm stopping and I'm thinking and I'm looking at the numbers, 41 is prime, 13 is prime. So 533 has 2 factors and 2 factors only, 41 and 13. So we're done with this problem. This is our area, the square root of 533. So that's how you could work with an isosceles triangle. And hint, it might be on a homework and it might be on a test. All right, so we are basically done with this lesson, except I want to show you the closing. So you had 2 closings for this week. Some people made a mistake and they did part of Thursdays when they were supposed to do Wednesdays. Make sure you've answered these 3 questions. Right? The 2 for Wednesday, which was state 2 differences between perimeter and area. And number 2, explain what the altitude or height of a figure is. And then today's closing, explain the mistake and find the correct area. All right, and show your steps. Don't just tell me the number. All right, explain what they did, what was wrong, all right, and then you find the correct one because this is wrong. And that's the end of my podcast. So if you need more time to look at this to answer the question, no problem. Just pause me now, and then you can take all the time you want on this closing. But me, I gotta go. All right, so have a good weekend. Bye.